Good day, everyone. My name is Shimpusan Jonas Okwachani, student number 1830782, module number AEL 3601. I'm here to present about the alternative energy design of healthcare service for rural area. I'll take you through my presentation, which I wrote it here. Let me just start with my content. We have the abstraction, objective, literature of review, theory of low voltage and installation, methodology and result, calculation of voltage drops, calculation of the required power, and calculation of a power rating of the components, and the conclusion of our presentation. Then we have the references where we checked how many people, we checked the references, then yeah, so on. In abstraction, the rural healthcare system in South Africa face the frequent power interruption due to national energy shortage. The impact of the reliability of the critical hospital equipment. The project of the pro, this project proposed an alternative solution using the hybrid solar wind system to ensure that uninterrupted power supply to rural hospitals. Using science standards compliance electrical design principle, the project develops full interior and exterior electrical layout and an estimated power requirement, specific material using a reputable brand. The design ensures that the hospital is self-sufficient and safe. The main objectives are not limited to capable of operating in a working range to access healthcare facility. Lack of economical privilege and affordability for public commutation fare. Poor sanitation, misuse of fertilization of chemicals during agricultural activities, crops, which time to time result to some diseases. The the appropriate energy deployment PTV production of a health facilities of such communities will be the best solution for health concern and to those who can't access to a clinic and immediately during a great failure. Introduction. Access to reliable energy is essential to effective healthcare deliveries. Globally, alternative energy solutions, especially solar and wind, have been widely adopted to support the rural and off-grid medical facility. In South Africa, the issue of load shedding has been prompt in a shift towards the decentralized renewable energy sources. Rural hospitals are particularly vulnerable due to infrastructure limitation, grade, and reliability. The report outlined the electrical design projects for hospitals. Objective: the aim of this aim is to develop an alternative energy design solution for a rural hospital in Sitlakona area located in Nagamudrimulema municipality northwest. It is where the producers where we did research on in Nagamudrimulema in northwest. The, the project has the following objective: to design a compliant electrical system, lighting, power, emergency system for a rural hospital using such regulation, to implement hybrid renewable energy system combining solar and wind power, to ensure that system can fully support all hospital operations during the grid outage, to prepare outline bill of quantity with brand specific reliability. Classification and requirement will be used to establish the design and reliability and alternative comparative assessment will be developed, evaluate reliability choices. Alternative power system may be authorized but limited to saving certain essential loads for the critical hospital and other special theory of low voltages. Voltage Voltage regulation is usually not a problem, but voltage drop for excessive long run and the voltage will be checked to ensure that the correct load voltage in the rotating load should be checked, made both in steady state voltage regulation. During starting and as in installation, there should be a protection against the thermal effect of overcurrent caused by any danger. Short circuit current depend on a solar irradiance, but it may also be lower than the grid trip value or trip value of an overcurrent protection. Although this is not an issue for cable as the current is within the current carrying capacity, the inverter will detect the voltage drop and stop producing power. It is therefore recommended that to disconnect a faulty circuit in case of short circuit. While a string overcurrent protection is required, each PVC string shall protect with overcurrent protection devices. Nominal current protection fuses or breakers rating for string overcurrent. The device shall be greater than 1.5 times the string, the 1.5 times string short circuit current ICS and mode below the 2.4 ICS mode. The nominal radius of the chip for overcurrent protection device of the PVC separate fuses and shall be greater than 1.25 times the separation in short circuit current ICSTC separate below 2.4 ISC separate. The selection of overcurrent protection rating shall be done in order to avoid unexpected trip and normal operation in considering temperature. Methodology. All healthcare facilities will serve by single-ended substation distribution and there will be sub-coordinated surge and fault protection in the primary services and will design a full demand with plus percentage payloaded. Transit protections systems will incorporate solid-state device and subsystem to the internal system transit that can cause and malfunction or equipment component damage. Grounding. Grounding shall be equated for safety or for level of operation, sensitive user and facility, and typical and communication system equipment used in hospital required for 5 ohms ground for proper operation. All ground will be bounded together required by NFP 70 and necessary surge arresting system will direct any unwanted quantum for each S rod employed in the grounding stipulated by some standard. A figures which shows that pictures here that shows the DC and AC, the inverter, diesel generator, and the load and the wind and PVC and the battery banks. And you also have the solar power panels and arrays. Also the PVC, the DC side, and also the AC and the breakers. Also all the wind going to the grid and it's also on. Then we have the layout here, the legend which shows our power supplies and LED and everything that is needed there. Then we have the electrical layout. This is our main circuit, how it's been stipulated. Then we have the power control circuit also here, and also our single line diagram. So here is our most important part. When you do a project, you must know each and every component that you're going to use, how much are you going to use, and how many components are you going to use. Your budget also is very important. The voltage calculations on electrical part, which is the most important thing, and so that you can know how many, which cables you should use, and how many watts for each and every equipment that you're going to do. The calculations of the circuit breaker requires cable, breaker size calculations, short circuit protection calculations, voltage drop calculations for each and every thing that you're going to do. And also, when we go through our conclusion of our after all the calculations of what is required in our presentation and the total and everything we need to do, we have already put it there, and the power rating calculation of our power rating component also is there. In the conclusion, the project demonstrated that the rural hospital can be reliable powered by a hybrid solar wind energy system with the complete electrical layout designed as per standard, and the system ensures that continued operation during the power outage while promoting sustainability and reduce operational cost. The comprehensive approach including lighting and socket outlet and emergency system, set layout, ensure compliance and safety. The use of high quality material, fabric and Schneider further enhance reliability. Wind turbine generation, the reason why the one didn't want it to fail because of the cost of maintenance of the tiny machinery and the geographic deficiency that cannot produce enough power. As for diesel generation, this form a fail for a major reason for environmental concern, which is emission, the smoke around, and which especially in health facilities, which we don't want any carbon monoxide or any emission. Nevertheless, solar comes from photons of the light that hits the solar panel within the light vicinity in the intents of forming electrons that are extracted from the positive side of the silicon solar cells. That make a panel. The sun provides more if enough energy to meet the whole world energy need. Unlike fossil fuel, it won't run out anytime soon. A renewable energy source and the only limitation of a solar power station is reliable to turn into electricity. Then we have our references here, which you should want to check from a hybrid energy development and also the reliability within ESCOM and the HEPS. Yeah. So this is the end of our presentation here. Thank you.